Section 7.3. In this section, we are going to learn how to use double angle formulas to find exact values, double angle formulas to verify the identities, reduction formulas to simplify an expression, half angle formulas to find exact values. First, we will start off with double angle formulas for sine, cosine, and tangent. Sine of double angle means sine of 2 times the angle. For example, if my original angle is A, 2 times A is double A. In this section, I am going to learn how to use the formula for sine of 2A. In order to derive the double angle formula, I am going to use the formula of the sum of 2 angles. So instead of 2A, I rewrote it to A plus A. And from here, I'm using the sum formula for sine. Sine of A plus A equals sine of A times cosine of A plus cosine of A times sine of A. From here to here, I'm using the sum formula for sine from section 7.2. At this point, I have sine of A times cosine of A, cosine of A times sine of A. So these two terms are like terms. We can combine them to 2 sine A cosine A. So my double formula for sine is 2 sine A cosine A. Next, we have double angle for cosine. I am going to do the same thing. I will rewrite 2A to A plus A. Cosine of A plus A equals to cosine A cosine A minus sine A sine A. From here to here, I'm using the sum formula for cosine that we learned in section 7.2. Cosine A times cosine A is cosine square A. Sine A times sine A is sine square A. So cosine of 2A is equivalent to cosine square A minus sine square A. There are 3 different variations for cosine of 2A. The first variation is cosine square A minus sine square A. The second variation is when you substitute cosine square A with 1 minus sine square A. You would have 1 minus 2 sine square A. The third variation is when you substitute sine square A with 1 minus cosine square A, you would have 2 cosine square A minus 1. These are all equivalent. You can use either one of these. Tangent of double angle is tangent 2A. And tangent 2A is equal to 2 tangent A over 1 minus tangent square A. Or you can use sine of 2A divided by cosine of 2A. Example 1. Given that tangent of theta equals negative 3 over 4, and theta is in the second quadrant, find the following. A. Find sine of 2 theta. B. Find cosine of 2 theta. C. Find tangent of 2 theta. The first thing I'm going to do is write down the formula for these double angles first. Sine of 2 theta is 2 sine theta cosine theta. Cosine of 2 theta is cosine squared theta minus sine squared theta. For these two formulas, I need sine theta, cosine theta. I need sine theta, cosine theta. The first thing I'm going to do is go ahead and find sine of theta and cosine of theta. The information that they gave me is tangent of theta equals negative 3/4. And theta is in the second quadrant. I want to find sine of theta and cosine of theta. I am going to use the Pythagorean identity. 1 plus tangent square equals secant square. My tangent is negative 3/4, so I'm going to substitute negative 3/4 in here. Negative 3/4 square is 9/16. 1 plus 9/16 is 25/16. And I'm taking the square root on both sides to solve for just secant. And once I'm taking square root, there's always plus or minus. Now, theta is in the second quadrant. So first, second, third, fourth. Second quadrant is here. So in the second quadrant, cosine and secant is negative. So in this case, I'm choosing the negative. So secant theta is negative 5/4. Secant is the reciprocal of cosine. So secant of theta is negative 5/4. That means cosine is negative 4/5. Cosine of theta is what I need for my formula for sine of 2 theta and cosine of 2 theta. Whenever I see cosine of theta, I can use negative 4/5 to replace it. Next, I need to find sine of theta. I am going to use the Pythagorean identity again. This time, I use sine square plus cosine square equals 1. Cosine is negative 4/5, so I substitute negative 4/5 in here and I square it. Negative 4/5 square is 16/25, and I'm going to subtract it from both sides. 1 minus 16/25 is 9/25. And I'm going to take square root on both sides. And don't forget the plus or minus. We have to choose the correct sign. Remember, theta is in the second quadrant. So in the second quadrant, sine is positive. So in this case, I am going to use the positive. So I have sine of theta equals positive 3/5. And this is what I am going to use for sine of theta in the formula. To find sine of 2 theta, I use the double angle formula. That is 2 times sine theta times cosine theta. Sine of theta is 3/5, and cosine of theta is negative 4/5. I am going to plug it in here. I have 2 times 3 times 4 is 24. 5 times 5 is 25. And the product is negative. So I have negative 24/25. For cosine of 2 theta, I have cosine squared theta minus sine squared theta. Cosine of theta is negative 4/5, and sine of theta is 3/5. I'm going to go ahead and plug it in. Negative 4/5 squared is 16/25. 3/5 squared is 9/25. 16/25 minus 9/25 is 7/25. For tangent of 2 theta, since I have sine of 2 theta and cosine of 2 theta, I am going to use the formula tangent of 2 theta equals sine of 2 theta over cosine of 2 theta. Sine of 2 theta was found. That is negative 24 over 25. Cosine of 2 theta is 7 over 25. So I have negative 24 over 25 times 25 over 7. 25 cancel out with 25. I end up with negative 24 over 7. Example 2. Use the double angle formula for cosine to write cosine of 6x in terms of cosine of 3x. They gave me cosine of 6x, and they say they don't like this angle. They want me to turn the 6x into cosine of 3x. Lucky that 6x is equal to 3x times 2, so I will start with that. I'll have cosine of 2 times 3x. So imagine if this 3x is an a, I have cosine of 2a. Use the double angle for cosine. Cosine of 2a is cosine square of a minus sine square of a. Cosine of 2 times 3x is going to be cosine square of 3x minus sine square of 3x. I was able to reduce the angle from 6x to 3x. However, they don't want to have sine of 3x in here. They only want to have it in terms of cosine of 3x. So I need to replace this sine square of 3x into something with cosine. I am using the Pythagorean identity. Sine square of 3x is equivalent to 1 minus cosine square of 3x. So I have cosine square of 3x minus 1 minus cosine square of 3x. I will go ahead and distribute the negative side out. After distribute the negative sign out, I have cosine squared 3x minus 1 plus cosine squared 3x. Cosine squared 3x and cosine squared 3x are like terms. I am going to combine them to become 2 cosine squared 3x. So from cosine of 6x, I'm able to rewrite it to 2 cosine squared 3x minus 1. Next, we have the reduction formulas. Reduction formula is used in order for us to reduce the power of the trig function. For example, if I have sine square of a, what can I do if I want to reduce the square power? Or what if I have cosine to the 6th of b? What can I do to reduce this 6th power? That is when we need to use the reduction formula. So to start with the reduction formula of sine, we need to go back to use the double angle for cosine. So these are the 3 variations of the double angle for cosine. Cosine of 2a equals 1 minus 2 sine square a. Cosine of 2a equals 2 cosine square a minus 1. I am going to use this one for the reduction formula for sine and this one for the reduction formula for cosine. So I have cosine of 2a equals 1 minus 2 sine square a. This is one of the variation of the double angle for cosine. From here, if I solve for sine square a, I would just subtract 1 from both sides first. So I have cosine of 2a minus 1 equals negative 2 sine square a. And then I divide both sides by negative 2. I have cosine of 2a minus 1 over negative 2. So sine square A equals cosine of 2A minus 1 divided by negative 2. This strict function has the power of 2, and this strict function has the power of 1. That means I have reduced the power from 2 to 1. And that is the reduction formula for sine. If I multiply top by negative 1 and bottom by negative 1, then I have sine square of A equals negative cosine 2A plus 1 over 2. The reduction formula for cosine, I am going to use the other variation of double angle of cosine. Cosine of 2A equals 2 cosine square A minus 1. And I am trying to solve for cosine square A. First, I'll add 1 to both sides. Then I'll divide both sides by 2. I was able to reduce the power of this cosine from 2 to 1 right here. And that is the reduction formula for cosine. And for tangent square A, I'll just take sine square A divided by cosine square A. I'll get 1 minus cosine of 2A over 1 plus cosine of 2A. Example 3. Write an equivalent expression for cosine to the fourth x that does not involve any power of sine or cosine greater than 1. They gave me cosine to the fourth of x. The power is to the fourth. They want me to rewrite this into something of sine and cosine, that the power here is not greater than 1. So I am only allowed to have cosine to the first or sine to the first power only. That is when I need to reuse the reduction formula. The first one I'm using is the reduction formula for cosine. So the reduction formula for cosine comes with cosine squared. So I'm going to rewrite cosine to the fourth into something with cosine squared. Cosine to the 4x is equivalent to cosine square x squared. 2 times 2 is 4. And in here, I am replacing cosine square x with 1 plus cosine 2x over 2. So this cosine square x is replaced with 1 plus cosine of 2x over 2 by using the reduction formula of cosine. So from here, I have a fraction raised to the square. That means I have the numerator square over the denominator square. So 2 squared is 4, and this 4 is in the denominator, so I'm going to bring it to the front to make it 1/4. And then from here, I am going to take 1 plus cosine 2x squared. 1 plus cosine 2x squared is 1 plus cosine 2x times 1 plus cosine 2x. I will have 1 plus 2 cosine 2x plus cosine square 2x. So I'm good with the first term. I'm good with the second term because this is cosine to the first power. I'm not happy with this guy right here. This has the second power. But again, I'm only allowed to have sine or cosine to the first power. So this guy right here. I am using the reduction formula for cosine again. I'm going to have 1 plus cosine of twice the angle over 2. So the angle here is 2. Twice of 2x is 4x, right? So remember, when you reduce from square to the first power, your original angle is double. So my original angle here is 2x. double of 2x is 4x. So I would have 1 plus cosine 4x over 2. Right, next I am going to just simplify everything out. So I have 1 plus cosine 4x over 2. That is equivalent to 1/2 plus cosine 4x over 2. Right, so I am going to combine like terms. 1 plus 1/2 is 3/2. And then I'm also distributing the 1/4 out. So 3/2 times 1/4 is 3/8 plus 1/4 times 2 cosine 2x is 1/2 cosine 2x plus 1/4 times cosine of 4x over 2 is 1 over 8 cosine 4x. The final expression, I have cosine to the first of 2x and cosine to the first of 4x. That satisfying the requirement that the power of sine or cosine is not greater than 1. Next, we have half-angle formulas. Imagine if you have sine of b over 2, cosine of b over 2, tangent of b over 2. These angles are called half-angle because it has the angle divided by 2. What are you going to do with that? That's why we need to come up with the half-angle formulas. In order to derive the half-angle formula for sine, we are going to use the reduction angle for sine. Sine squared a equals 1 minus cosine of 2a over 2. So look at the relationship of these two angles. This is a and this is 2a. This is always double this. So if this is 2, this is 4. If this is 5, this is 10. If this is 20, this is 40. So imagine now if I replace this a with b over 2. I will have sine squared of b over 2 equals 1 minus cosine of something over 2. So this angle is always double of this angle. Now this angle is b over 2. This will be double of b over 2. So double of b over 2 is 2 times b over 2, which is b. I have the formula for sine squared of b over 2. But what I want is just sine of b over 2. I want to get rid of the square power right here. So in order to do that, I need to take the square root on both sides. And when I take the square root on both sides, there's always a plus or minus. So the half-angle formula for sine is sine of b over 2 equals plus or minus square root of 1 minus cosine b over 2. Plus or minus, your answer can either be plus or minus, not both. You have to choose the correct sign that is corresponding to your angle. So for example, if the angle b half is in the first quadrant, then sine of b over 2 is positive. If the angle b half is in the third quadrant, then sine of b over 2 is negative. Similar to cosine of b over 2, I will use the reduction angle formula for cosine. Cosine squared of a equals to 1 plus cosine of 2a over 2. So look at the relationship of these two angles. This angle is double this angle. So whatever I put in here, this will be double that. So if I replace this with b over 2, this angle right here will double this. So double of b over 2 is b. And in order to derive the formula for cosine of b over 2, I'll take the square root on both sides. And always, when you take the square root on both sides, there's always plus or minus. Cosine of b over 2 equals plus or minus square root of 1 plus cosine b over 2. Again, you have to choose either plus or minus that is corresponding to your angle. For tangent of b over 2, I am taking sine of b over 2 divided by cosine of b over 2, which is plus or minus square root of 1 minus cosine b over 1 plus cosine b. Example 4. Find sine of 15 degree using a half angle formula. In this example, they want me to use half angle formula. I don't have any other option. I have to use the half angle formula. So I'm thinking 15 degree is half of 30 degree. I am going to rewrite 15 into 30 divided by 2. And I am using the half angle formula for sine. So I have plus or minus square root of 1 minus cosine 30 degree divided by 2. I have to choose the correct sign for my answer. It's either plus or minus. And this depends on my angle. My angle is 30 divided by 2, which is 15. 15 degree is in the first quadrant, right here. 15 is half of 30. So sine of 15 degree, sine in the first quadrant is positive. So in this case, my correct sign is positive. That means I can just ignore the negative sign. So from here, my answer is positive. You don't have to write out the positive sign here. I just want to emphasize that so you can see. 1 minus cosine of 30 degree. 30 degrees right here, and cosine of 30 degree is root 3 over 2. So I have 1 minus root 3 over 2, and then divided by 2. I will take 1 minus root 3 over 2. I replace 1 with 2 over 2. So we'll have 2 over 2 minus root 3 over 2, which is 2 minus root 3 over 2, and then over 2. Simplifying this, I will have the square root of 2 minus root 3 over 4. I cannot take the square root of the numerator, but I can take the square root of 4. So I'll have square root of 2 minus root 3 over 2. Example 5. Given that tangent of alpha is 8 over 15, and alpha is in between pi and 3 pi over 2, which is in the third quadrant, find the exact value of the following. I want to find the exact value for sine of alpha over 2, cosine of alpha over 2, and tangent of alpha over 2. In order to find sine and cosine of half angle, I need to have cosine of alpha. From here, they gave me tangent of alpha. I can use the Pythagorean theorem. 1 plus tangent square alpha equals secant square alpha. 1 plus tangent is 8 over 15. I substitute that in. 8 over 15 squared is 64 over 225. 1 plus 64 over 225 is 289 over 225. And to find secant of alpha, I'll take the square root on both sides. And don't forget plus or minus. Alpha is in between pi and 3 pi over 2, which is in the third quadrant. Secant of an angle in the third quadrant will be negative. So secant of alpha is negative 17 over 15. And I want to find cosine. Cosine is the reciprocal of secant. So cosine of alpha is negative 15 over 17. And I will use this information to plug into the formulas of half angles later. A. Sine of alpha over 2. I am going to use the half angle formula for sine, which is plus or minus square root of 1 minus cosine alpha over 2. Should it be plus or minus? It depends on which quadrant the angle alpha half is in. I know my angle alpha is in the third quadrant, but I have no idea about alpha half. So I need to figure that out. I know that alpha is in between pi and 3 pi over 2. For easier calculation, I'll convert these into degrees. Pi is equivalent to 180 degree, and 3 pi over 2 is equivalent to 270 degree. So I know alpha is in between 180 and 270. What happened to alpha half? Well, I just need to divide it by 2, and divide this by 2, and divide this by 2. So 180 divided by 2 is 90 degree, less than alpha half, less than 135. Alpha over 2 is in between 90 degree and 135 degree. 90 degree is here, and 135 degree is here. So my alpha half is from here to here. It's in the second quadrant. In the second quadrant, sine is positive. So in this case, sine of alpha half is positive. And I am substituting cosine of alpha with negative 15 over 17. Minus negative is positive. I'll take 1 plus 15 over 17, which is 32 over 17. And that is 32 over 34. And that is 16 over 17, which is 4 over square root of 17. This is your answer. However, if the homework asks you to rationalize the denominator, that means they don't want to have the square root in the denominator, you will have to multiply top and bottom by the square root of 17 to have 4 times square root of 17 over 17. These both are correct answers. It just depends on how they want to see the answer. If they want you to rationalize the denominator, then this is what they want. B. Cosine of alpha over 2. I am using the half angle formula for cosine. That is plus or minus square root of 1 plus cosine alpha over 2. Now, I have to choose the correct sign for cosine of alpha half. Alpha half is in the second quadrant. Cosine of an angle in the second quadrant is negative. So this is going to be negative. I am substituting cosine alpha with negative 15 over 17. 1 plus negative 15 over 17 is 2 over 17. So I will have negative square root of 2 over 17 over 2. Simplifying this, I'll have negative square root of 1 over 17. Simplifying this, I'll have negative 1 over square root of 17. This is your answer. However, if they ask you to rationalize the denominator, then you will need to multiply top and bottom by square root of 17. These two answers are equivalent. This is rationalize the denominator, and this is not. For tangent of alpha half, I can use the half angle formula for tangent, which is plus or minus square root of 1 minus cosine alpha over 1 plus cosine alpha. However, I found sine of alpha half and cosine of alpha half. In this particular case, I am going to use the formula tangent of alpha half is sine of alpha half divided by cosine of alpha half. Sine of alpha half was found in part A, 4 over square root of 17. Cosine of alpha half was found in part B, negative 1 over square root of 17. And I'll just simplify this fraction. I'll have 4 over square root of 17 times negative square root of 17 over 1. Square root of 17 canceled out. I end up with negative 4.